One other thing that we want to do with these trig identities is to simplify things and verify things. We did this a little bit last year in Algebra 2, but honestly not a whole lot. So what we're going to do is use our trig identities to transform the left side of the equation into the right side. We want to show that these two things are equal. So we are not allowed to switch things over to the other side of the equation. We're just working with one side at a time. So we have on the left side tangent theta times cosecant theta. So I don't know. Let's maybe write these in terms of sine and cosine. Remember that tangent, let's get a pencil, that's going to be easier to use here. Tangent is sine over cosine. And then cosecant, we can rewrite that as 1 over sine. So we do that. Then notice the sines are going to cancel out. So we get 1 over cosine equals secant. And then 1 over cosine, that is the same thing as secant. So we have turned the left side of the equation into the same thing as the right side. Mission accomplished. We're going to try the next thing on the other side. So we're not going to do anything with the right side, just the left side. Let's FOIL this, okay? So we get cosecant squared theta minus cosecant. Oh, sorry, that was cosecant, not cosine. Minus cosecant plus cosecant. Oh, my word, it's so hard to write. Minus 1. Those cancel out, so we end up with cosecant squared theta minus 1 equals cotangent squared theta. And then I think that left side, if you go look at, let's go look at those trig identities. That looks a lot like one of the Pythagorean identities. Yeah, this one, that's what I was thinking of. Okay, it looks a lot like that, except it's not quite. The left side is cosecant squared minus 1. Oh, so if you just subtract 1 from each side of this, you get cotangent squared is cosecant squared minus 1. So we can use that substitution in here, okay? That means that this thing is just cotangent squared, and that's equal to the other side, cotangent squared. So we got them to equal each other. Mission accomplished on that. So when we're using these trig identities to transform stuff, it's kind of like putting a little puzzle together, and we'll do some more practice with that as we go on. All right, the last thing that we are going to do with these is what's called solving a right triangle. Solving a right triangle means you find all angles and sides. So to do that, you may use the Pythagorean theorem, you may use the fact that all the angles have to add up to 180 degrees, and you might use your trig relationships like SOHCAHTOA. All right, then we have two other terms, angle of elevation. So angle of elevation is like, this is you on the ground and you're looking at a bird up in the tree, okay? There's the tree and you're just far away on the ground. So you're looking up at the bird. The angle of elevation is this, how far your eyes go up, okay? So angle of elevation right there. The angle of depression is the angle that the bird is looking down at you. So these are always measured from the horizontal. So the angle of depression is this. Okay, that is key there. Angle of depression is always measured from the horizon looking down. Okay, so we'll see those in some of our word problems. Now, just for the sake of time, I am only going to do number 8. You can check out the notes, the PDF of the notes for the last two. They're pretty straightforward. So we have a 6 foot tall person, okay, 6 feet tall. They are 19 feet from this flagpole. Hang on, I think. And they measure the angle of elevation. So this is the flagpole. There it is. 19 feet. And the angle of elevation, so from their eyes to the top of that flagpole, is 64.6. Okay. We want to know how tall the flagpole is. So I'm going to call that side X. So as we look at this, we did these back in geometry and in Algebra 2. From this angle, you can see that this is the opposite side, and this is the adjacent side. So the trig function, if you're thinking about SOHCAHTOA, the trig function that uses opposite and adjacent is tangent. So we say that the tangent of 64.6 equals x over 19. And then to solve this for x, we're going to multiply both sides by 19. So in your calculator, you're going to do 19 times the tangent of 64.6, and I think it's right around 40. Okay. Now, this is not quite our answer because remember that's this length, x. We also have to include the 6 feet. So our final answer is going to be 46 feet. Again, check out the PDF for the answers to the next two examples.